So now you may ask the question, okay, we are learning the binomial distribution, but what is there for me as a data scientist, as a data analyst, or as a statistician? What is there for me to work with machine learning model? Is there anything that will benefit me when I work on machine learning models? That's what I'm going to tell you now. So first one, it will be useful in A/B testing. The binomial distribution can be used to model the outcomes of A/B tests, which are commonly used in online experiments to compare the effectiveness of different strategy. So if you take an example, imagine an online retailer is testing two different versions of a web page to see which one leads to more sales. They randomly show each version of the web page to 100 visitors and record how many of them make a purchase. The number of purchases the number of purchases made by each group of 100 visitors follows a binomial distribution which can be used to calculate the probability that one version of the web page is more effective than the other. Next, that's one. And second one is quality control. The binomial distribution can be used to model the number of defective items in the production process, which can help identify whether the process is within accepted limits or not. If we take example, suppose a company is producing light bulbs and they want to ensure that no more than 2% of the bulbs they produce are defective. They can use the binomial distribution to model the number of defective bulbs in a sample of bulbs and calculate the probability that the production process is within the acceptable limits. And the third one that we have is a risk analysis. So the binomial distribution can be used to model the probability of a certain events occurring, such as the likelihood of a certain number of credit defaults in a portfolio. So if you take one example, imagine an insurance company wants to estimate the probability of a policyholder filling a claim. They can use the binomial distribution to model the number of claims filled by a group of policyholders and calculate the probability of a certain number of claims occurring. Then survey sampling, very important. So the binomial distribution can be used to model the outcomes of survey questions with binary responses such as yes or no questions. So if we take a small example, so survey sampling, suppose a political polling organization wants to estimate the proportion of voters who support a particular candidate. They can use the binomial distribution to model the number of voters who say they support the candidate in a sample of voters and calculate the margin of error and confidence interval for the estimate. And finally, the most important one, that's the machine learning. Machine learning. So the binomial distribution can be used as a prior distribution for Bayesian models, which are increasingly used in machine learning. So some of the benefits of using binomial distributions in machine learning model are predictive accuracy. The binomial distribution can help improve the accuracy of predictive models by providing a more realistic probability distribution of the data. And second one, interpretability. The binomial distribution provides a simple and interpretable framework for modeling data, which can help data scientists understand the underlying data generating process and make more informed decisions. Then flexibility. The binomial distribution can be easily modified to accommodate different types of data, which makes it a versatile tool for data scientists and working in a variety of fields. So if we take one example, The binomial distribution can be used as a prior distribution for Bayesian models, which are increasingly used in machine learning model. For example, in natural language processing (NLP), a binomial distribution can be used to model the probability of a certain word appearing in a sentence, which can be useful for text classification and sentiment analysis. So these are just a few examples, but the binomial distribution has many other applications in different fields, demonstrating the versatility and usefulness in modeling data.